Hello, in this video we're going to be talking about bulk transport. Let's not waste any of your time. Let's get right to it. Alright, so when we're talking bulk transport, okay, we want to not think about active transport principles, passive transport principles. This is a new set that really doesn't have any principles like those two, but it's very unique in the fact that we're talking large molecules or particles. Okay, super large. They can't fit through proteins. They can't fit through any other way. So essentially, what happens is this is like, you can, park your car in the garage or in the carport. But if you brought in a semi or a big dump truck, okay, now all of a sudden that can't get into the normal situations, and we got to come up with a different way. And the bulk transport is really where the flexibility of the membrane really comes into play. But there are four things that we're going to talk about. Three of them bring in materials. One of them helps to exit materials. But it's still going to cost us some energy, and you'll see why, because there's a lot going on. But we got phagocytosis, pinocytosis, receptor-mediated endocytosis. Those all bring materials in, and they each have their own slides, so we'll talk about that. And then exocytosis releases materials, but the way in which it does it is pretty phenomenal. It changes and alters the landscape of the phospholipid bilayer, but the phospholipid bilayer, just takes it in stride and adapts and moves on. Alright, our first one we're going to talk about is phagocytosis. And this term simply refers to engulfing something, and in this case moving it. If it was a lysosomes, as we talked about in organelles, also phagocytized thing, but then they go and dissolve it. But in this case, simply what we have is we've got on the outside of the cell a very large molecule that needs to come inside the cell. So essentially what happens, as you can see in the picture there beside me, is the particle approaches the plasma membrane, and the membrane simply wraps around it and then pinches off, okay, and it floats into the cell inside of that vesicle of phospholipids, and then the two separated parts of the membrane just simply reconnect. Okay, just simply reconnect, and the membrane goes back to the way it was. So that just speaks of the adaptability, the flexibility of the membrane. Now, the membrane will do the same thing for all three types that bring materials in. What they're bringing in is different, okay, but the idea of just engulfing the particle, pinching that vesicle off, and it floating in, and then the idea of the two ends of the membrane rejoining to reconnect the membrane happens in all three types. Okay, so here's our next type, pinocytosis. This has more to do with the volume of liquid as it brings in the material. Maybe the solution is more, or the particle is in a solution. Okay, something along those effects, but the same idea occurs. The plasma membrane just engulfs it, okay, pinches it off, and the rest of the molecule, the rest of the membrane just reattaches, okay. And again, the flexibility nature of that is what the fluidity of the membrane in the mosaic, the fluid mosaic model is all about. Now, just by picture alone, you can see that the receptor-mediated endocytosis, okay, is a lot different than the first two that we saw. Okay, so in the first case, it's got these receptors. Okay, we talked about molecules needing to be identified before we just freely let them in. Okay, it's the same case here. You've got the receptors that have to recognize the molecule, and then once it's been signed off that it's good, then again the membrane just engulfs the material, pinches that off, and it floats into the cell. Now, the difference that we can see here in this picture is these clarithrins. These clarithrins are little proteins that help strengthen that area that's going to be carrying or bringing in the material. Now, the clarithin, it happens in all of the types, in phagocytosis and pinocytosis. It also happens, but the difference is in the clarithin in the receptor-mediated endocytosis stay on during transport. In the first two, they're there as the process is engulfing, but then they go away once that happens. But in receptor-mediated endocytosis, the clarithin stay to strengthen the outside of the vesicle the entire time. And our fourth member of the bulk transport party, exocytosis. So now we're going to be doing the exact opposite. Instead of taking material in and engulfing it and then pinching that off and floating inside, now we're going to be releasing material. Okay, and here's the way this works. The vesicle or lysosome in some cases would approach the membrane. The membrane itself would open up, separator split, as well as the vesicle will open up. And then the two free ends on the left will attach, and the two free ends on the right will attach, and then the material is free to float away. But then what happens is the vesicle remains a part of the membrane. So in the first three we saw, the membrane gives up a little bit of itself to make a vesicle. In this case, the vesicle adds to the membrane's amounts and remains with it. Again, that just speaks to the flexibility, the adaptability of the membrane to take all that, to do all those different types. Well, that's our video for today, and this is also our last video for this series. So this is chapter 5. So the next time we get together, we'll be looking at energy. We'll see you then.